All right, so finding the limiting reagent in mole is simple. Just look at how much it has, right? How much it get used. Take a look here. So the whole thing is 1:1 ratio. You can do the balance equation, but this is all balanced already. All right. So which means that if you look at the number of sulfur trioxide, so we got 20 moles. We have 20 moles of sulfur trioxide and 10 moles, only 10 moles of water. Okay. If you look at just the moles of sulfur trioxide, you should get 20 moles of sulfuric acid. Does it make sense? They're 1:1 ratio. All right. But if you look at the moles of water, we have only 10 moles of water. You should get 10 moles of sulfuric acid. Does it make sense? All right. Now, which one is a real theoretical yield? The 10 moles. You can make 20 moles from here because water is gonna run out first. Who's the limiting reagent? Water, of course, because it runs out first. Okay. So how many moles of excess reagent are left over? How many moles? Well, I'm gonna do this, right? At the beginning, we have 20 moles of sulfur trioxide, 10 moles of water, 0 mole of sulfuric acid. Let it react, so I use delta, so it changed. Water runs out first, so we're going to use all up. Use all of them, use all up. All right? So if I use 10 moles of water, how many moles of sulfur trioxide do I use? 10 moles. They're 1:1 ratio. Yeah, 10 moles as well. And how much sulfuric acid do I get? They are all 1:1 ratio, 10 moles as well. 10 moles here, 10 moles there, 10 moles there. And the final, what you're going to get? Well, the number of reactant going to be lower. The number of product going to be higher. So negative here, positive there. Okay. So start with 20, use 10. We're going to be left with 10 moles of sulfur trioxide. 10 here, use all 10, so 0 for water. And sulfuric acid, so we get 10 moles of sulfuric acid. All right. So that's a leftover. That's a theoretical yield. Okay. All right. Let's try right here. So uranium react with fluorine gas according to this equation. If 30 moles of uranium would react with 75 moles of fluorine gas, how many moles of UF6 will form? Uranium hexafluoride. Okay, so we want to find moles here. So first of all, you need to know which one runs out first, who is the limiting reagent. All right, so more calculate the theoretical yield. Okay, so moles of uranium hexafluoride, they can be formed from 30 moles of uranium, right? They are 1:1 ratio. That's how I do it. Just convert moles here to moles of uranium hexafluoride. So put moles of uranium at the bottom, moles of UF6 at the top, cancel out. If you look at just the 30 moles of uranium, you should get 30 moles of uranium hexafluoride. Does it make sense? 1:1 ratio. Now, if you look at the moles of fluoride, just fluorine gas. Okay, so we have 75 moles of fluorine gas, but watch out, it's 3:1 ratio. We use this guy up more quickly than using uranium. All right, so 3 moles of fluorine, 1 mole of uranium hexafluoride. All right, so mole cancel out. You're gonna get 25 moles of uranium hexafluoride. Look at that. So who's the real limiting reagent? This guy right here. Right, this guy will run out first because it gets used 3 times faster than the uranium does. Okay, and so this guy is a limiting reagent. Now, how many moles of UF6 are left over? You can do this too. Let's take a look. That's what we start with. Right, at the beginning, no uranium hexafluoride used yet, so we have 30 moles of uranium, 75 moles of F2 fluorine gas. We use all F2. 75 moles. All right, we use all of F2. All right. Now, how many moles of uranium are we using? Well, they're 3:1 ratio, right? They're 3:1 ratio. 75 is 3. 1 ratio divided by 3. You should get 25 moles. All right. And also same thing. We should get 25 moles of uranium hexafluoride as well. All right. I'll say one more time. We use all of fluorine gas, right? So 75 mole gonna get used up. Now, how much uranium gets used up? Well, it's 3:1 ratio. If you use 75 here, it's only 25 here. 3-to-1 ratio, use 75, produce 25. Okay, and the reactant, so the amount of reactant should be lower, negative here. So fluorine gas is run out. Uranium got 5 moles left, and uranium hexafluoride is produced by 25 moles. That's how we do it. Okay. All right. One more time. So it could be complicated here, but it's not really complicated. This is simple math. All right. So don't make this complicated. All right, phosphorus react with chlorine gas according to this equation. All right, it looks like it's already balanced. If 25 moles of phosphorus combined with 50 moles of chlorine gas, what is the limiting reagent? How many moles of the product PCl3 can be produced? All right, phosphorus trichloride. Okay, so first off, find out who's the limiting reagent first. All right, so who runs out first? Let's say just look at just look at the moles of phosphorus. We have 25 moles. How many moles of PCl3 can be produced? Right? They are 2-to-2 ratio. So that's 2-to-2 ratio. So I'm going to put moles of phosphorus at the bottom and moles of the product at the top. The moles cancel out. You should get 25. It's 1-to-1 ratio. You don't even have to do this. It's 1-to-1. 25 here, 25 there. Now, chlorine is 3-to-1 ratio. You probably have to do the math here. All right. So find the theoretical yield. Just look at the number of chlorine. So we have chlorine gas, 50 moles of chlorine gas. All right. Convert moles to moles of the product. So put moles at chlorine at the bottom, moles of product at the top. 3-to-2 ratio. Yeah, 3-to-2. Moles of chlorine cancel out. You should get that number, 33.3 moles of phosphorus trichloride. So who runs out first? Phosphorus. So produce the lowest number of the product here. So because this guy runs out first, right? Now, so this limiting reagent. Now, how many moles of PCl3 are produced? How many moles of PCl3 are produced? Well, they're 1-to-1 ratio, right? 25 moles. That's it. That's a theoretical yield, right? If you want to do the math right here, you can also do the math right here. I'll show you. At the beginning, no product is formed yet. Phosphorus, we use all of them, the whole thing. Use the whole thing, all right? 25 moles of phosphorus. How many moles of chlorine do we use up? 2-to-3 ratio. So we have to do the math right here. Okay, so moles of chlorine from moles of phosphorus. 25 moles of phosphorus convert to moles of chlorine. It's the 2-to-3 ratio. 2-to-3 ratio. All right, mole of phosphorus at the bottom cancel out, and you're going to get 37.5 moles of chlorine. There we go. All right. Now, moles of PCl3 produced was 1-to-1 ratio. 25 here, 25 here. And the rest is simple math here. So use all up. Phosphorus, so 0. Chlorine get left over, 50 minus 37.5, 12.5 moles. And 25 moles here. Here we go. All right. All right. All right. So it's quite long. It's a long process. If you have problem following this with me, well, email me. We can Zoom and I'll clear this up for you. Okay. Or on YouTube, there's a lot of video talking about this. I mean, you can look all those up, but don't hesitate to email me or to Zoom with me. We can talk all the time. All right. Just let me know when. Okay. All right. Let's moving on.